Okay, good morning. Um, I am a bit tired today. I was up part of the night battling TypeScript, which often happens, and I get really frustrated. Like, yeah, I was thinking about how I was building Cerebral, and then I went over to building Overmind. And the reason I did that was because of TypeScript. And what's really sad about that story, like I learned a lot, and TypeScript is was awesome to explore in terms of creating the best consumer, like developer experience. But it's still like in the big picture, like trying to make coding more approachable and fun, and not having to do so much coding, just building the freaking thing. Like diving into TypeScript, that's not the way to do it. It's like moving back because it's all about the code. Well, the plan for Cerebral was to move even further so that you would actually be able to build your app using a visual editor, which is really sad. So if like TypeScript hadn't popped up, I would probably have built something like that, which is really annoying because I think that would be way more important than trying to solve all these TypeScript issues. So yeah, I'm kind of pondering about that a little bit. But anyways, we are back in our app. And I did this little experiment. Okay, so let's see if we deploy the new version of Overmind. So let's see if that works first. Overmind next, Overmind React next. Because we wanted to add like a derived to our state machine, and that didn't work. But it should work now. Where did we have that derived? Was it right here? Yeah, backlog list. Here we have the derived. And I guess it's okay. Because it crashed. Oh. That's not good. You're mutating the path state, but it's not allowed. It isn't? Did I break something now? God damn it. Or maybe we're running two versions of Overmind. That might be. Because oh, god damn it. Okay, so there's still something, but this doesn't really matter because I wanted to do something else today. How the hell did this break when I fixed the other thing? That's strange. That's really, really strange. Yeah, suddenly I can't transition anymore. Is that because Oh, maybe, yeah, so maybe I broke... No, that's really weird. Yeah, it's kind of weird, but okay. I'm not sure what's happening there, but let's look at this other thing that I played around with. So I was thinking about one of the tricky things about Overmind is that you write imperative code, and like typically you write imperative code in classes, like you have an object-oriented approach to programming. But what we're doing in Overmind is like using just plain functions. So it's more like an action is just a function. So the function doesn't have any of its own state, which is a good thing. Like we pass in the context and they do everything on that context. But you're not actually able to add something to that context. So things like creating listeners and stuff like that, like subscriptions, you can't really do that. And this was also the case with React. Like the functional components, you didn't have any state in them. You were only able to operate on the input and then return something, which is how functions work. But the way React handled this was to introduce hooks. So hooks allows you to introduce state like a context, and the same context runs every time the function runs. which is like super interesting and works kind of well for React. There are of course issues with that. It's very difficult, like mentally, to think about this function as a layer of multiple executions, where some of the, like when you use functions within that function, like callbacks to use effect and stuff, those are kind of like, so you can imagine like you might have 10 layers of this function running, where you have like one use effect is on the first, well, like initializing the state and the so initializing the state is on the first frame, and then it runs again, and suddenly that doesn't mean anything anymore, setting that initial state on the second frame or the second execution of the function. And then you might have like a function, but that function has like a dependency to certain changes to a state. So then you're on like a third frame, and now that function that you initialized on the second frame is still on the second frame while you are on the third frame, and then you're on the fourth and the fifth frame, and suddenly that function in use effect is suddenly reevaluated on the fifth frame. So it's kind of like you have to build this massive mental image of what's happening, and I don't think that's like the downside of doing that. There are benefits as well, but there are like especially the composition, but there are definitely downsides as well. So with a class approach, you have a more explicit concept of, you have a class instance, you have some state on a class instance, and then you can always like explicitly reference that. And that context is shared between, every time you call a method, it's the same context you're operating on. So you don't have this like layered thing. But the problem with classes is that they're very difficult to extend. Like, which is kind of weird, because you have like, it has an extend keyword. So you can like extend a class, but that's kind of the only thing you can do. You can only extend like another class. You don't have this possibility of composing together multiple classes and kind of giving functionality to the class like you can do with hooks. And this was kind of, if you worked with React a long time ago, this is also how React worked initially. You had like this create component function where you had the concept of mixins. And I don't remember the arguments for, so like mixins had an issue where they could override each other. Yeah, because the mixins, they were overriding lifecycle hooks and stuff. It was difficult to compose those correctly, something like that. It had like this overriding nature, which hooks doesn't have. Yes, but in the context of like writing business logic, like we do with Overmind, or especially these state machines, I thought I would try to build like an API that is based on state machines. And it's a class instance, because you do want to reference like local state for the machine, but you also want to build like public state, and that public state should be observable. So I built this thing where you have a class instance, it has some public state, and that public state uses proxy state tree, which is the same thing Overmind uses. And it's like highly inspired. So let's see, let's create like a state machine. Class foobar machine, and then that extends state machine. And this thing is that like in my experience building these blocks of managing business logic and state, I haven't really seen the need to compose them together. They are typically expressed as, this is one thing, and then you have something else that's something completely different. So unlike components, where you might have like a use scroll to top thing, and then you want to kind of use that in different components. but yeah, so the way this works is that you point to state machine, and then you say a state machine of, yeah, let's define the states first. So the current is either foo, or the current is bar. So we want to create a state machine of these states. Now I should get like the same kind of API that we have currently in our app. And then I define the initial state. So that's foo. So now I have this machine and I can instantiate it. Foo bar, new foo bar machine. Yes. And now you can imagine like the rest of this thing here is now related to building up the logic for it. So by default, I can do console.log foobar, and it has state, and I can point to current, like that's the only state I have now. And when I do that, we see foo. And if I go to foobar transition to bar, then we log out again, it transitions to bar. And then it has all the functionality we've been talking about, like typed matching and transitioning and all this stuff. But what's kind of interesting is that when we have this way of writing the logic now, we have the possibility to, well, maybe I can show you first. So let's introduce some state here. So foo has like a foo string kind of thing here. Foo bar. There's lots of foo bars. So what I can do here now is I can introduce like change foo. Then I can say this state.foo. Yeah, of course I have to check if this matches foo first. And that gives me the typing for foo. And that equals like bar 2. And then instead of doing this transition, I can say foo bar change foo. And then let's, yeah, I guess I have to, let's just log out state. That's easier. So now it changed to, oh yeah, this console in Codesandbox, it's async. So you might get, it might actually display like a mutation after it happened. So I should like, okay, let's do if foo bar matches foo. Yeah, that's actually quite confusing. And then we'll just do foo here instead. There you go, bar and bar 2. So basically you introduce all your actions just as methods here. But then you also have some of your own methods. Or it has its own methods. So things like, we can explore them, foo bar. So you can do on enter, on exit, on transition, you have reaction, you can terminate the machine, you can do tracking on the machine, and then of course you can do a transition. Which I think is quite interesting, because then you can do things like, okay, I want to do something here every time, like maybe there's a piece of state that changes different places. You just want something to happen when you change some piece of state. So then you can use a constructor called super thing, and then you can say this reaction, we can point to, let's see, state. So for example, if state current equals foo and state current, state foo. Okay, so whenever, let's see, let's put that on the next line. Changed foo. And then we can do like changed foo, and we can like, oh, come on, changed foo. Oh, come on. Oh, man. Sorry, I'm a bit tired today, so I do a lot of mistakes. if changed foo this.log foo, for example. And then we do that. Console.log this.state. Yeah, I have to check if it actually matches foo. Console.log this.state foo. Anyways, so what you can see now, okay, let's type reaction. So what you can see now is that when we went ahead and changed the foo now, we have this reaction that triggers, and we are able to actually instantiate that with the machine. And this machine could now, since it's a constructor, so you could pass it other machines, for example. And then you could listen to, you could have reactions to other machines. So if you had like a child machine that changed some state, you could react to that in this machine. Now, the point is dispose reaction. Void. So you can say this.dispose reaction. So for example, the first time this happens, we are going to dispose the reaction. And then we can do like a change foo again. And it should really just, well, let's do plus equals something like that. Yeah, and then we can log out again. And as you can see, like now I was able to have a reference to the subscription of that reaction in the state of the machine itself. And that allows me to dispose of that subscription. So you can do all sorts of crazy stuff here. I'm not sure if that's a good idea, but it really is. I think it's interesting. So what happened here, like where this idea comes from, is like looking at xstate, which is declarative, which is a really good idea because then you can build visual tools on top of it. So I think xstate is going to be really, really, really good when they get to the point of doing visual tooling, because then you don't care about the complexity of the declarative code underneath. Well, this approach is imperative, which means that you kind of explicitly tell the machine to do in different contexts, which gives you a lot more flexibility. But you could never create like a visual tool for this because there's like no data structure to kind of analyze. You don't get like it's at least extremely difficult to interpret what's happening here. But if you just have an object describing what's happening, then it's much simpler. Yes, so in that sense, being like imperative, it's not good for visual tooling on top, but it's good for the flexibility of expressing complex machines. And what proxy state tree helps with is to expose public state that is observable. That's like a huge benefit, and it protects you. So when you try to change that public state asynchronously, if you're doing transitions in a complex manner, it protects you. So it throws an error if you try to change the public state when you are in the wrong transition state. Sorry. Okay, anyways. So what you can also do here, as you can see, you pass in some initial state. You can also override that state. So we can go in here and we can say like current is not foo, it's bar, for example. And that will override, so if we save now, I guess nothing happens because it doesn't match anymore. So you have this possibility to kind of say, no, I want to pass in the initial state, or maybe you want to do this for testing. So you can say like initial state is states, for example, and then initial state, and then we would have to pass it in here. Oh, and this is type, oh, states. Oh, sorry. Yeah, I guess it's because I haven't defined current yet. So current is foo, for example. Well, that will be the same. So now I would need foo bar, but I can do bar here instead. So like this. Anyways, so you can like instantiate the machine with custom state for testing and stuff. And yeah, so the way I look at this is that what you would do here is that you would actually, so what we're doing now, we're having a machine that's dealing with we're changing some public state, but you can use these. So in Overmind, you have like actions and effects. Those are two different concepts. So I imagine like in this world, you would have, you would use state machines for everything. So if you want like a fetch machine, you would just create that like new, oh, let's create the class first. Fetch machine extends state machine. State machine of fetch states. Oh, sorry. Fetch states, blah, blah, blah. Let's type that. Type fetch states. And that would be like current idle. Then it would move to current fetching. And then it would move to current success. And then current error, for example. Yes. So we would say if you're idle, you can go to fetching. If you're fetching, you can go to error or success or error. And if you are on error, you can go to yeah, I guess you can go to fetching again. And if you're on success, it can move to, I guess, fetching. Cool. And then current would be idle, something like that. Now the point is that, oh, what did I do? Oh, sorry. So what you could do is you could, for example, introduce like a generic here. So it extends like, yeah, well, it can be anything. So, and then you could say something like, okay, fetch states should be of t. Like this is some crazy TypeScript stuff, but it's interesting. So on success, we would then say result would then be t, right? And here the error would be like a string or something. I'm not sure what it's complaining about here. What are you complaining about? Base class expressions. Oh, for fuck's sake. What does that mean? Base class expressions cannot reference class type. They can't? Why can't they do that? Oh, you know, after dealing with TypeScript this tonight, like this night, this is pissing me off. Why the fuck can't you do that? This seems like an obvious thing. This is the same as passing like why can't I do that? Okay, if I do extends fetch oh, maybe it's if I would do this, I guess I can't do that either. No, I can't do that. Like, how the hell do I pass a generic type to this thing? That really sucks, because the idea here was that you would be able to create a new fetch machine by telling like what are you trying to fetch, but you can't really do that, which sucks big time. But can I do like state machine? Can I do, oh wait a minute, is it possible to express this like this? Fetch states. No, you can't do it like that, can you? State machine, no, because that would be no, it would have to be like this, but this also is not working. Thanks for that. Value of type of state machine. Did you mean include new? I don't know what I meant. Okay, so I can type down states there, which kind of sucks. Like how would I don't understand how I would do this. So you couldn't have this off thing. You would kind of just do, so for example, god damn it. So you could do something like this. So states t. You can't even do that? Oh, sorry, fetch state. So you could do that, but you can't continue working on that. So there's no good way to express the transitions and the initial state. Because I think that's kind of the clue here. That's when it kind of made sense to me, is that you could actually express the transitions and the state when you extend the machine, so that you can choose it there, because that's like a configuration thing. Like if you were to set it in here, it wouldn't make any sense, because it wouldn't be like required, and it would just be really weird. You could pass it into super, but then you would have to have the constructor and doing super, and then you would have the transitions and initial state inside the constructor super, which looks really bad. But this looks really great. But of course, TypeScript is yelling, like always. Like always. Yeah, but maybe state machine of transitions. Yeah, I find that really weird that that isn't allowed. It doesn't make any sense at all. It's the same thing. What does the hell does it even mean, base class expressions? I think we're going a little bit over time now. Base class. Okay, so is this the same kind of thing? Class extends base. Oh, I didn't know I could write it like that. I can change that. I don't really have to name this thing. I can just return a class that extends. Yeah, of course it doesn't fix our issue, but so what the hell are they doing here? Constructor, get tag. So they are tagged base tag. Oh, it's passing it after? That's interesting. But oh, so it's rather passing in the constructor. So you would do like yeah. But I know the constructor, so I don't care about that. Class T extends base. Is it because the base doesn't have the same thing? So this has like a generic, but the thing that we're returning here doesn't have it? But that doesn't make sense. That doesn't make any sense. What's it is it saying now? No base specified number of, oh wow, this is super confusing. Maybe there's a better answer there. I have the same question. Doesn't seem like there's a good way to express this. But I guess it's because this is like this static thing is being evaluated before this thing or something like that. It's probably a good reason, but it kind of completely breaks the whole concept because you wouldn't have to be able to do this. Like I'm so sick and tired of TypeScript dictating how my APIs should look, especially when they like it seems intuitive that it should work, and then for some technical reason it doesn't. And it's not TypeScript's fault, it's just it's incredibly difficult to statically analyze code, especially when you have these APIs that are kind of pushing the limits. But that's the frustrating thing. We're pushing the limits of coding. We're not pushing the limits of building things, which is what I talked about, like what I should focus on. I'm really tired of focusing on TypeScript. Oh. Okay. I guess we are not able to fix this now. But anyways, it was like, I think the API is interesting in terms of like being this alternative to a declarative approach. So you get more flexibility and can be more straightforward. You have like an observable state instead of immutable state and stuff like that. But yeah, maybe I'll see if I can fix this, and it would be kind of fun to see how it worked in the app, just for fun's sake. But we'll see what happens. Anyways, a little bit tired today. In a pretty and I'm like in a I'm tired because I'm been working on TypeScript all night, and I'm angry with TypeScript, and now we got into a TypeScript issue again, so it's kind of god damn it. Anyways, have a great day, and I'll talk to you tomorrow, I guess. Okay, bye bye.